Hello friends, the topic for today is diesel cycle under the course Basics of IC Engine. This is presented by me, Harshit Agarwal. I have done mechanical engineering from NIT Nagpur in 2008. I have cleared the Indian Engineering Services examination. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared GATE exam as well. Regarding course fee, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. So to start with diesel cycle or the constant pressure cycle. If you remember, the Otto cycle is also known as the constant volume cycle and diesel cycle is also known as the constant pressure cycle. There are four processes in diesel cycle. 1 to 2 is a reversible adiabatic compression process. This is a PV diagram and this is a TS diagram. In PV diagram, reversible adiabatic process is from 1 to 2. 2 to 3 is a constant pressure process. Constant pressure heat addition. If you remember, in Otto cycle, 2 to 3 was a constant volume heat addition. Similarly, 3 to 4 is a reversible adiabatic expansion. In Otto cycle, 3 to 4 was a reversible adiabatic expansion. Same. From 4 to 1. 4 to 1 is constant volume heat rejection. In the Otto cycle, there was also 4 to 1, it was constant volume heat rejection. Here in diesel cycle, 2 to 3 is constant pressure heat addition. There in Otto cycle, 2 to 3 was constant volume heat addition. Similarly, you can see this in TS diagram. 1 to 2 is reversible adiabatic compression. 2 to 3 is constant pressure heat addition. 3 to 4 is reversible adiabatic expansion. 4 to 1 is constant volume heat rejection. These are the four processes, as you can see this in PV diagram as well as in TS diagram. Now, there are some important terms. Compression ratio, I have already discussed with you. Compression ratio is V1 minus V2. Compression ratio is V1 minus V2, which is Vs plus Vc upon Vc. Similarly, there is one more term, cutoff volume. Cutoff volume and cutoff ratio are totally different terms. Cutoff volume is V3 minus V2. It is not V3 by V2. Keep in mind these two terms. Cutoff volume is V3 minus V2 and cutoff ratio is V3 by V2. Cutoff ratio is, it is the ratio of volume after heat addition to the volume before heat addition. So the cutoff ratio is V3 by V2 and cutoff volume is V3 minus V2. So the cutoff ratio RC is V3 by V2. Similarly, there is one more term, expansion ratio. Expansion ratio, it is the ratio of volume after expansion to the volume before expansion. So the expansion ratio is V4 by V3. So there are three ratios: compression ratio, which is V1 by V2, cutoff ratio, which is V3 by V2, expansion ratio, which is V4 by V3. These are the three important terms in diesel cycle, right? So we have to find a relation between these three terms, between compression ratio, cutoff ratio and expansion ratio. As we have already discussed, expansion ratio is V4 by V3, compression ratio is V1 by V2, cutoff ratio is V3 by V2. We can always write compression ratio is equal to cutoff ratio into expansion ratio. Cutoff ratio is V3 by V2, expansion ratio is V4 by V3. So we can write here V4 by V2. We can cancel V3, so the compression ratio is V4 by V3. But V1 is equal to V4. V1 is equal to V4. So the compression ratio is V1 by V2. So therefore the final answer is compression ratio is equal to cutoff ratio into expansion ratio. This is the final relation. Keep this relation in your mind. This is a very important ratio. Compression ratio is equal to cutoff ratio into expansion ratio. So next comes the derivation of efficiency of diesel cycle. As we have derived the efficiency of Otto cycle, it was 1 minus 1 upon r raised to power gamma minus 1. Similarly, we have to derive the efficiency of diesel cycle. We already know that efficiency is net work done upon heat supplied. Net work done is heat supplied minus heat rejection. Heat supplied at constant pressure, which is from 2 to 3, and heat rejection at constant volume, which is from 4 to 1. So efficiency is Qs minus Qr upon Qs. So heat supplied at constant pressure is mCp delta T minus mCv delta T upon mCp delta T. This Cp term, what we have done over here is like 1 minus Cv upon Cv, T4 minus T1 upon T3 minus T2, T4 minus T1 upon T3 minus T2. Similarly, Cp by Cv we all know is gamma. So the relation becomes 1 minus 1 by gamma, T1 by T2. We have taken T1 common, T4 by T1 minus 1, and from denominator we have taken T2 common. So it becomes T3 by T2 minus 1. So this is one relation, 1 minus 1 upon gamma, T1 T2 T4 by T1 minus 1 upon T2, T3 by T2 minus 1. So we all know that 1 to 2 is a reversible adiabatic process. From that relation, we can write T2 by T1 equal to V1 by V2 raised to power gamma, which is R raised to power gamma minus 1. So we have deduced T2 by T1, which is efficiency is equal to 1 minus gamma 1 minus 1 upon gamma into 1 upon R raised to power gamma minus 1. This R is compression ratio, and in bracket this is the result. We have to eliminate this T4 T1 and T3 T2. So taking this 3 to 4 adiabatic, which is T3 V3 raised to power gamma minus 1 equal to T4 V4 raised to power gamma minus 1, and also using this relation which I have already told you, this relation is very important, which is compression ratio is equal to cutoff ratio into expansion ratio, which is expansion ratio is equal to compression ratio upon cutoff ratio, which is T3 by T4 is equal to R raised to power gamma minus 1 upon RC raised to power gamma minus 1. This comes from here. T3 by T4 is equal to RE raised to power gamma minus 1. Therefore, T3 by T4 is equal to 1 upon RC raised to power gamma minus 1 into T2 by T1. Therefore, T4 by T1 is equal to T3 by T2 into RC raised to power gamma minus 1. So, the final result is T4 by T1 is equal to RC raised to power gamma. So, final result for the efficiency of our diesel cycle is 1 minus 1 upon R raised to power gamma minus 1 into 1 upon gamma. In bracket, it is RC raised to power gamma minus 1 upon RC minus 1. This is the efficiency of diesel cycle, which depends upon two things. One is the cutoff ratio as well as compression ratio, but the efficiency of Otto cycle depends only on one thing, that is the compression ratio. Keep in mind, efficiency of Otto cycle depends on compression ratio, but efficiency of diesel cycle depends upon compression ratio as well as cutoff ratio. Now, many a times question comes in exam, if you increase the cutoff ratio of diesel cycle, will the efficiency increase or decrease? So many times this question has come in IES as well as in GATE examination. So the heading is effect of variation of cutoff ratio on efficiency. As you can see, 1 2 3 4 is the original diesel cycle, and the condition is increase in cutoff ratio. So 1 2 3 dash 4 dash is a new cycle. We have drawn this cycle in PV diagram. Similarly, we are drawing this cycle in TS diagram. In TS diagram, 1 2 3 4 is a normal diesel cycle, and 1 2 3 dash 4 dash is a new diesel cycle with increase in cutoff ratio. You all must be knowing that I have already told you 2 to 3 is a constant pressure heat addition, and 4 to 1 is a constant volume heat rejection. On TS diagram, constant volume has more slope as compared to constant pressure. So the rate of heat rejection is more as compared to rate of heat addition, because heat rejection is taking place at constant volume and heat addition is taking place at constant pressure. So the rate of heat rejection is more as compared to rate of heat addition. So the efficiency is 1 minus QR by QS. QR is increasing, QS as compared to QS. So the efficiency will decrease. So the final answer is, with increase in cutoff ratio, the heat rejection occurs at a faster rate at a constant rate, because heat rejection occurs at constant volume and slope of constant volume line is greater than the slope of constant pressure line. So with the increase in cutoff ratio, efficiency will decrease for a diesel cycle, because the heat rejection is occur at a faster rate. Thanks a lot from my side. Engineering services is really very easy exam. Be focused, be concentrated. Thanks to all of you.